Hi, welcome back to Moose and Chemistry. This is John Dalton's Theory Explained. Now, John Dalton in 1808 came up with a theory to explain subatomic particles called atoms. First of all, he said in 1808, all matter is composed of extremely small particles called atoms. Where have we heard that before? Didn't Democritus say that like over 2,000 years before John Dalton? I think so. So Dalton kind of like maybe borrowed a bit of that from Democritus. But could Dalton prove this? Now remember, in ancient Greece when Democritus said it, he had no way to prove it. Now it's 1808, nearly 2,000 years later. Can John Dalton prove it? And the answer is no. Because in 1808, the best microscopes they had were light-powered microscopes, and they had maybe 30x magnification. Even today, our electron microscopes, which have literally millions of magnifications, still cannot see atoms directly because they are so small. What we can see, however, are the shadows of atoms. So, again, John Dalton took that leap of faith to say that all matter is created of atoms. All right, now, the second thing he said was that atoms of a given element are identical in size, mass, and other properties. Atoms of different elements are different in size, mass, and other properties. So basically what he's saying is this. Fluorine atoms are all the same. And also, he's saying that carbon atoms are all the same. That's very true. But now, look what he says now. Atoms of different elements are different in size, mass, and other properties. So what he's saying is that a fluorine atom is nowhere near like a carbon atom. And that is absolutely true. So John Dalton got that right. Although Dalton couldn't see atoms at the time, he knew that fluorine atoms were structurally different than carbon atoms. Okay, here's the curious thing. John Dalton said that atoms cannot be subdivided, created, nor destroyed. So what are we really saying when he says that? He says that you can't split an atom apart. He says that you can't make an atom. And he says you can't completely destroy the atom. Well, we know that's no longer true. In nuclear chemistry, we can certainly subdivide atoms. We can create brand new atoms. And we can turn atoms into energy in nuclear chemistry. So this statement no longer is true. So what they've done to modernize his thought, they have now say that atoms cannot be subdivided, created, nor destroyed in an ordinary chemical reaction. So what we're going to do is we're going to just base this on John Dalton 1808 for now, and we're going to go ahead and kind of get rid of that statement. All right, so that's been blotted out. Now remember that chemists today have changed that statement to saying that atoms cannot be created, subdivided, or destroyed by ordinary chemical means. Not nuclear means, by the way, but by ordinary chemical means. All right, let's look at statement number 4. Atoms of different elements are combined in simple whole number ratios to form compounds. Okay, let's take lithium plus chlorine yields lithium chloride. So we've got to put a 2 there to balance, put a 2 there to balance. Oh, look. Whole number ratios, 1, 2, 1. Let's look at another example. Okay, let's see here. I got it. Let's take sodium plus oxygen to yield sodium oxide, right? So now, of course, you got to put a 2 here. Let's see here. Yes, put a 2 here. And we have to put a 2 here. So if you put a 2 there, you're going to need a 4 here. Actually. There you go. And now everything's balanced, okay? And so now let's look at this thing. This is a 2-to-1 ratio. Again, there are no fractions, simple whole number ratios. And let's look at statement number 5. It's kind of like statement number 4. In a chemical reaction, atoms are combined, separated, or rearranged. So let's combine some atoms. Let's see. Okay, let's do beryllium plus fluorine yields beryllium fluoride. Okay, atoms are combined. We make that. Let's say you have H2O, breaks down into hydrogen plus oxygen, right? So you're going to put a 2 there and a 2 there to balance this equation. But now they're separated and rearranged. Let's look at an example of being rearranged. Let's say we take hydrochloric acid plus sodium hydroxide, and we're going to make sodium chloride plus H2O. And let's see here, that looks balanced. So yes, that's it. These are the 5 statements that John Dalton came up with in 1808. But remember his statement number 3, atoms cannot be subdivided, created, nor destroyed, is no longer true because we have nuclear chemistry. So we can create atoms, we can subdivide atoms, and we can certainly destroy atoms. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosing Chemistry.